everyone, welcome to our deep dive into the fascinating world of self-projection and the brain. I am Tilbe and today we will be exploring how our minds can travel through time and space, allowing us to remember the past, anticipate the future, and understand others' perspectives. We will be discussing insight from the groundbreaking article Self-Projection and the Brain by renowned research by Buckner and Carroll. Randy Buckner is a distinguished professor at Harvard University with affiliations to the Center for Brain Science, Department of Psychology. His work has significantly advanced our understanding of the brain's default mode network. Daniel Carroll is a notable researcher in cognitive neuroscience, contributing extensively to our knowledge of mental simulations and memory. Today, we are going to unveil the complex concepts of self-projection, which is the ability to mentally transport ourselves to different times, places, or perspectives. This process is crucial for planning social interactions and navigating our environment. Our discussion will be centered around a simple yet relatable scenarios, a picnic. We will use this scenario to illustrate the different forms of self-projection and how they are represented in our brain. In this image, we see a person at a picnic table, and various true bubbles represent different forms of mental simulation. These include first-person and third-person views, each demonstrating a unique aspect of self-projection. But before we dive into the specific, let's briefly outline what we will cover today. We will look at the remembering past events, anticipating future ones, understanding others' perspectives, and navigating our environment, all through the lens of self-projection. By the end of this video, you will have a better understanding of how these mental processes work and why they are so important for our daily lives. So let's get started. Prospection is more than just daydreaming about what's to come. It's a complex cognitive function deeply rooted in our brain structure and history. This concept emerged prominently in the mid-19th century with the case of Phineas Gage. Gage's accidents, which damaged his frontal lobe, highlighted how essential these brain regions are for planning and executing socially appropriate behaviors. Fast forward to modern times, and we have identified specific neural activity patterns that maintain past stimuli and anticipate future action, forming the basic for future-oriented behavior. The term prospection has evolved through various fields, including psychology and neuroscience. It's been referred to as episodic future thinking, memory for the future, and mental time travel, among others. Researchers like Ingraver have suggested that our brains spontaneously engage in prospection even when we are not actively focused on specific tasks. Self-projection is a multifaceted cognitive ability that allows us to mentally transport ourselves across the time and space. This capability is fundamental to various cognitive functions such as planning, social interaction, and spatial navigation in the central skin of our illustration. We see a person at a picnic table. The surrounding true bubbles represent different forms of self-projection, remembering past events, anticipating future events, understanding others' perspective, and navigate our environment. The ability to simulate past and future events as well as to understand others' perspectives relies on a complex network in our brain. Research led by Buckner and Carroll has shown that this network includes regions such as frontal lobes and the default mode network. These regions are highly active even when we are at rest, indicating their crucial role in supporting self-projection. Let's look at the image which was shown in the article. Uh, in the first, let's look at remembering shown in the bubble A. This involves recalling a past event like a previous picnic. This form of self-projection allows us to relive past experience, which is crucial for learning and forming a coherent sense of identity. And the second one is we have prospection illustrated in bubble B. Here, our mind simulates a possible future event, such as cleaning up after the picnic. This ability to anticipate future scenarios help us prepare and make decisions, ensuring we can navigate future challenge effectively. And thirdly, in bubble C, we see the theory of mind at work. This involves understanding another person's perspective, like considering the mental state of someone we are asking to help clean up. This cognitive function is vital for empathy and social interactions. And finally, bubble D. It illustrates navigation or topographic orientation. This form of self-projection allows us to create a mental map of our surroundings, like locating the nearest trash bin at the picnic. Effective navigation helps us move through our environment efficiently. The neural basis of prospection is intricately linked to the brain's default mode network, which includes frontal region along the midline, lateral and medial parietal regions, and the medial temporal lobe. This network is highly active during passive states, such as daydreaming, and plays a critical role in self-projection tasks like remembering and imagining future events. Firstly, let's looking at the box 1. It's a history of prospection and the brain, and the observation of planning deficit in patients with frontal lobe lesions led to an understanding of the neural basis of the prospection. The case of Phineas Gage revealed structures in the human brain dedicated to planning and executing suitable behavior. Neural activity patterns that maintain representations of past stimuli and anticipate future actions suggest mechanism for future-oriented behavior. Interestingly, the brain's energy consumption remains constant whether we are at rest or solving complex problems. This implies a continuous, extensive brain activity in the absence of immediate tasks. Research like Marcus identified this pattern and labeled it the default mode. This default network is remarkably similar to regions active during the prospection, suggesting a shift from external perception to internal stimulation of different worlds. And in here, second box 2 in the article, talking about the default mode and its relation to self-projection. The brain's energy consumption remains constant from rest to active cognitive states. PET analyses confirm a pattern of increased brain activity during passive states compared to the active states. The default network includes frontal regions, parietal regions, and medial temporal lobe structures, as I told before. And the default mode network is similar to regions active during self-projection, indicating a shift from external to internal cognition. While we have made significant strides, many questions remain. For instance, how do specific lesions in the medial temporal lobe affect self-projection? What experimental practices can effectively study prospection? Moreover, can we identify problems that can only be solved through self-projection? These questions are crucial as they can reveal unique functional adaptations related to planning, social judgment, and complex organizational skills. And in here, box 3 coming arise. Its questions and feature directions. Self-projection and simulation concepts are vague and need more precise terms. Investigate medial temporal lobe contribution to self-projection through lesion studies. Developed experimental pragmatisms for studying prospection. Explore the overlap between the default mode and self-projection. Identify problems uniquely solved by self-projection, such as planning and social judgments. To sum up, prospection is a vital cognitive function deeply embedded in our brain's architecture. From Phineas Gage early revelations to the sophisticated image studies of today, we have seen how our brains are wired to think about the future. The default mode network plays a really important role maintaining internal simulation even when we are at rest. As we continue to explore this field, we can expect to uncover more about how we plan, predict, and navigate our lives. Thank you for joining me on this journey through the brain's incredible ability to project into the future. I encourage you to delve deeper into this topic and share your thoughts and questions in the comment below. Don't forget to like, subscribe, and hit the notification bell for more insight into the world of neuroscience. Until next time, keep exploring the future. Thank you for listening.